Hello everyone, welcome back. Let me try to solve some of the important problems uh, which will be trying to understand these things. Okay, so let us try to understand it. Okay, uh, now the topic which I'll be discussing here is on successive differentiation. Okay, okay. Fine. So that's what we'll be trying to understand it. Okay. Let us try to understand these concepts as of now. So before we start to understand this, okay. Now let us see what is f dash of x. Okay. What is f dash of x? Okay. So f dash of x is d by dx of that function which is f of x. Okay, this is what is f dash of x. Okay, and f double dash of x is uh, again differentiation of this with respect to x. Okay, and f dash of x. So f double dash triple dash of x will be again d by dx of that f dash double dash of x, and so on. So if you look into the nth term of that, so this will be fn of x, which is d by dx of f of n minus 1 of x. Okay, so that's that. Now, while understanding these concepts, let us try to understand a few of the things. Okay. Uh, okay. Let me start with the problem itself. Let us see the nth derivative of e to the power of ax. Okay. Let us see that. Let us see that nth derivative of e to the power of ax. Now the function is e to the power of x. So when you differentiate for the first time, it is, I mean, let me d by dx of e to the power of ax. Okay, so that would be a into e to the power of ax. Okay, so likewise, if you have for the nth term, if I represent this as d, so d as d by dx, if I represent that, so that would be, okay, that would be a to the power of n e to the power of ax. Suppose if I put 1, then n as 1, I get the same result. Okay. Likewise, we have nth derivative of log of a plus ax plus b. Okay. So again, we have that. Okay, nth derivative of this. So the formula corresponding to that would be uh, of log of ax plus b, this would result as minus 1 to the power of n minus 1, okay, and it is n minus 1, okay, fine, n minus 1 factorial into a to the power of n. This divides by ax plus b to the power of, okay. So this is for the nth derivative of log of uh, ax plus b, okay. Now let us see the nth derivative of let us see that also, nth derivative of this is ax plus b to the power of m, okay, ax plus b to the power of m. Now again, for this it would be, that is, if you try to find it, so we'll have a few cases in this when m is equal to n and so on, so we'll have so many results of that. So if I consider that, okay, we have uh, if I consider that as dn of ax plus b to the power of m, okay, so that would be so n is equal to m if I consider, so this will be m n. So if I find that, so I'll get as n factorial a to the power of n, so that will be the result, okay. So likewise, let us move on to the problem itself, okay, wherein I'll try to explain you how to solve it, okay. So let me take one example, okay. Let us find what is a to the power of mx, okay. So nth derivative of a to the power of mx, okay. So if I take logarithms on both sides, if I consider this as y, okay, so will be log y will be uh, m x log a, okay. This will be log y is equal to mx log a, fine. Now differentiating this, I get, if I differentiate, this will be y1, okay. This is 1 by y, okay, this is dy by dx, and this is 1 by y, and uh, this will be m log a, okay. Further, if I simplify it, okay, so I need y1, so that will be m log a into y. Now let us find what is y2. So please try to remember what is y1. Y1 is dy by dx, okay, y being this. Y2 will be d square y by dx square, which I have already mentioned in the class itself, okay. Now this will be y2 of m log a into y1. Okay, which is equal to y1 is this result. So this should be m log a whole square into y. Okay, so y3 if I take, this is y2, y3 if I take m log a whole square, and this will be y1. But again, we have that y1 as this result. So this is m log a whole cube into y. So y cube is this. Fine. So let me again go for y power n. So y power n, I mean yn, okay, y1 it would result to m log a this power n into y. So we have m log a power n into y, which is a to the power of mx. So this is the nth derivative, or we can write this as d power n, and this is a power mx. This will be the nth derivative. So I hope you understood this. Let me try to solve the next problem. Fine. Now let us move on to the next problem. Uh, if I have, that is log of a square x square minus b square. Okay, let me try to solve this problem. So nth derivative of this. Okay, now let us put this as since this is a square minus b square form, I'll put this as log of a x minus b or plus b and ax minus b. Okay, so now this will be log of ax plus b plus log of ax minus b. So I get this now. Now this will be separately. I'll try to find what is uh, dn of this. Okay, the nth derivative of this. Nth derivative of this would be of a log of a square x square minus b square. Okay, so this will be dn of log of ax plus b, and this is dn of log of ax minus b. Fine. Let us again uh, move further. Now we know this result earlier. Please try to remember that. Okay, that would be minus 1 to the power of n minus 1. Okay, this would be n minus 1 factorial. Okay, a to the power of n divides by ax plus b to the power of n, plus you have, and that would be minus 1 to the power of n minus 1, okay, into n minus 1 factorial into a to the power of n. Now this would change, so that would be ax minus b to the power of n. So that's the okay. So hence we are showed this. Let us move further to solve this. Suppose I have to solve for another problem. Let me try to solve that also as, as of now. Now let us take log to the base 10, okay, into 3x square plus 5x minus 2. Okay, let me try to solve this. Fine. Now this would be, if I consider to the base uh, 10, okay, if I can separate that log e to the base 10, okay, multiplied with log of 3x square plus 5x minus 2 to the base e, which is the same. Since this is constant, we can keep that like that only. And uh, 3x square plus 5x plus 2, we can find the factors corresponding to that. That would be 3x minus 1 into x plus 2. 3x minus 1 x plus 2. So if I have this, so I can log e to the base 10. Okay, so this will be log 3x minus 1 to the base 10 e to the base e plus log of x plus 2 to the base e. Now let us find the nth derivative for this. So this will be minus 1 to the power of n minus 1. Okay, fine. And n minus 1 factorial, if I take common, 3 to the power of n divided by 3x minus 1 to the power of n, okay, plus 1 to the power of n is 1 again, so this will be x plus 2 to the power of n, close the brackets. So that will be the nth derivative. Okay, so let me try to solve few more examples. Okay, let us see another example. Please concentrate on this, so which is very important for us to. Okay, let us see one more example. So, okay, now suppose I have to find the nth derivative. Okay, the nth derivative. Okay, that would be uh, sine h(a)x. Let us find the nth derivative of this. Okay, how to solve this? Now sine h(a)x is 1 by 2 of e to the power of ax minus e to the power of minus ax. Okay, now let us find what is nth derivative of this sine h(a)x. So this should be uh, nth derivative of e to the power of ax minus nth derivative of e to the power of minus ax. So this is what we are trying to solve. Now this can be written as half of e to the power of n e to the power of ax. Okay, minus, now this is minus, so it is minus of a to the power of n. Okay, e to the power of minus ax. Also, if you take an as common for both, so I get e to the power of n divided by 2, okay, e to the power of ax minus minus 1 to the power of n e to the power of minus ax. So that will be the nth derivative of this. Okay, now let us find the next problem. Okay, uh, for nth derivative of the cosine and sine. Okay, let us see how to solve this. So suppose if I have cos hax, okay, and if I have sine hbx, let us find the nth derivative of this. How to solve? Okay, now this can be written as 1 by 4 times, okay, that of a plus b to the power of n. Okay, e to the power of ax, I mean a plus b into x minus a minus b to the power of n, I'll have, and e to the power of a minus b into x plus, okay, so b minus a, fine, b minus a n power n e to the power of b minus a into x, and we'll have minus of, this is again minus of b, uh, tell me, plus a to the power of n e to the power of a, or if I consider minus b plus a. into x. So close the brackets. So that is that. Okay. So further, if uh, I this will be the solution for the cos HAX and sin HAX, sin HBX. Okay. Now let me try to solve the next problem. Okay. Let us find the nth derivative of x plus 3 divided by uh, x minus 1 into x plus 2. Let us try to solve this. This is uh, now by solving partial fractions. Let us put this as a divided by x minus 1 plus b divided by x plus 2. Now let us solve for a and b. What are the values of a and b? So if I take x plus 3 as a times that of x plus 2 and b as x multiplied with x minus 1. If you take x is equal to 1, okay, I get a as 4 by 3. If I take x as minus 2, I get b value as, if I try to simplify it, I get as 1 by 3. So I got here as 4 by 3 times that of 1 by x minus 1, and this is 1 by 3 that of 1 by x plus 2. Now let us find what is the nth derivative of this. So that would be, I'll have 4 by 3, okay, which is outside. Okay, so this will be minus 1 to the power of n and n factorial divided by, I'll have x minus 1 to the power of n plus 1. Okay, and I'll have 1 by 3. This would be minus 1 to the power of n into n factorial divided by x plus 2 to the power of n plus 1. So this will be the solution. Okay, let me try to solve another problem, okay, of same type with partial fractions, okay, which are important. Okay, suppose if I have x divided by x plus 1 into 2x minus 3. Okay, so let us find the nth derivative of this. So again, partial fractions, a divided by x plus 1 and b divided by 2x minus 3. Now again, if I take x as is equal to 2x minus 3 and b is x plus 1. Okay, if I take x as minus 1, okay, I'll get a value which is 1 by 5. Now if I take x as 3 by 2 here, okay, I'll get b as 3 by 5. I'll get b as 3 by 5. Fine. So let us substitute it. So I'll get 1 by 5 as common for both. Okay, this is for 1 by x plus 1. Okay, and this will be 3 by 5 for 1 by 2x minus 3. Fine. Let us find the nth derivative if I consider this as y of this. So that nth derivative of this would be this is d power n and this is d power n. Okay, so that would be 1 by 5 that of minus 1 to the power of n into n factorial divided by x plus 1 to the power of n plus 1 plus this is 3 by 5. Fine. So here also you'll get of this form minus 1 to the power of n and n factorial the 2 to the power of n divided by 2x minus 3 to the power of n plus 1. So that is the solution. Okay. We'll continue again after the break. Okay. Please do come back. Thank you for listening and have a nice time.